my screen. So here also what we have two plates. One is 16 mm and one is 14 mm thick, are to be joined by groove weld. Okay, groove weld are butt welds. A joint is subjected to a factored tensile force of 430 kilonewton. Due to some reasons, the effective length of the weld that could be provided was only 175 mm. Check the safety of the joint if provided single V weld and double V weld. Okay, so the question is this way: we have two plates, one is 16 mm, one is 14 mm. We have to transfer a certain factored tensile force. That we could provide was of 175 mm only. Okay, so we have to check if the joint is adequate or not. First, we have to check with single V groove weld, and second, we have to check with double V groove weld. So first case, let's check. So it is a 410 Fe 410 grade plate. The yield strength will be 250 megapascal. Now, in case of single V groove weld, there shall be incomplete penetration. We know already the throat thickness will be reduced. How much it will be? It will be 5/8 of T. What is T? T is the thickness of the thinner plate or the smaller thickness. So this is the throat thickness. Now, the factor of safety we have to consider here. Okay. Assume the plates to be shop welded. It is told in the question. Now, in this case, the allowable strength is not given considering the factor of safety. Therefore, in our equation, we shall have to consider the factor of safety for shop welding is 1.25. We know these things already. If we go to IS 800, we have the code and we have a table over there giving out the different factors of safety. The effective length of the weld is given in the question 25 mm. Now we will find out the strength of the weld. Now this is the strength of the weld. This TE, that is a throat thickness, and this LW, that is a length. Now this is giving us the total area of the weld multiplied by the yield strength. This will give us a value of strength. That value has to be divided with the factor of safety to find out what is going to be the design strength. Okay, so very easy. Don't be afraid. It is last like the earlier one only. We have the effective length, then we have the throat thickness. This will give, these two is going to give us the total cross-sectional area of the weld multiplied by the yield strength, and then we have to divide it with the factor of safety. If we do that, we get 306.25 kilonewton, which is less than 430 kilonewton. There was the factor force that we had to transfer through that joint. Therefore, the welded joint is inadequate. We cannot provide a single groove weld. Okay, so we shall have to consider the double V groove weld. Now let's check what is the strength in double V groove weld. Now in this case, there will be complete penetration of the weld, and therefore the thickness of the joint will be the thickness of the thinner plate, 14 mm. Okay, thickness of the throat thickness, we will say throat thickness is thickness of the thinner plate, which is 14 mm. We will go to the same formula. LW, the effective length, 175 mm multiplied by the throat thickness, 14 mm in this case, multiplied by 250, that is the yield strength, divided by factor of safety. It is coming out to be 490 kilonewton, which is greater than 430 kilonewton. So the design strength is 490 kilonewton now. The force that we have to transfer is 430 kilonewton. It is less, the strength is more, therefore the joint is adequate and safe. Okay, very easy. Then again we have another numerical. Now in this, again, we have a tie member. What is a tie member? Again, a tension member. In a truss girder, 250 mm by 14 mm size, it is welded to a 10 mm thick gusset plate by a fillet weld. Now the weld, this is welded to a 10 mm thick gusset plate. Okay, I read it twice. The overlap of the member is 300 mm. This is the overlap. Okay, this is our gusset plate. This is our the tie member. The overlap is 300 mm. The 250 mm by 40 mm size, 14 mm size. Therefore, the depth is going to be 250 mm, and the thickness is going to be 14 mm. The overlap of the member is 300 mm. Done. The weld size is 6 mm. Determine the design strength of the joint if welding is done as shown in the figure. What is the increase in the strength if welding is done all around? Assume shock welding. Okay. So same thing, Fe 410 grade. So the ultimate strength is 410 megapascal. The yield strength is 250 megapascal. For soft welding, the factor of safety is 1.25. Now we will calculate the effective length of the weld. How much? 300 mm here, 300 mm here, and 250 mm here. So 2 into 300 plus 250, this is going to be 850 mm. What is going to be effective throat thickness? K into S. We know K is dependent upon the angle of the weld. Again, we are considering a 90-degree weld. Therefore, K is going to be 0.7. So 0.7 into S is giving us 4.2 mm. This is our throat thickness. Now this formula is coming from IS 800. Okay, LW, that is the effective length. TW, the throat thickness. Fu, when we consider the ultimate strength, we have to take root over 3, so that it is going to be around yield strength, and then we have to divide it with factor of safety. Okay, if we do that, we get this value 676.05 kilonewton. Okay, so LW is what? LW is the effective length of the throat thickness, sorry, effective length of the weld. TW is the throat thickness. Fu is the ultimate strength of the safety, 1.25. Okay, now this comes out to be our design of the weld. And now in the second case, we are asked when welding is done all around. Okay, down all around. Here also we have welding. So the effective length is now going to be 300 plus 250 multiplied by 2. This is going to be our effective length of the weld. Design strength, same formula. Effective multiplied by throat thickness multiplied by the ultimate strength divided by root over 3, and then again divided by the factor of safety. We are using the same formula, and what we are getting this value. So ultimately, how much increase we have in strength, we just have to subtract from the value where we did welding all around. So we get, okay, this much kilonewton is increased strength of the joint. Okay, so that will be all for today.